Good day, everyone. Welcome to Flip Lectures in Chemistry. Today we will be talking about solutions and solubility. Solutions and solubility. When we talk about solubility, solubility is the term used to describe the maximum amount of solute that a given solvent can dissolve to give a stable solution. So when we talk about solubility, solubility aims to achieve what we call equilibrium for a solution. A very good example of a condition wherein equilibrium is attained is when the rate of dissolution equals the rate of crystallization for the formation of solid crystals. When the rate of dissolution equals, therefore, to the rate of crystallization, solution will already be in the state of equilibrium. When we talk about solutions are actually formed out of the combination or the dissolution of solute in a solvent. So there are basically three different types of solution. When we talk about saturation and equilibrium to be specific, at equilibrium, there is no change in the net amount of dissolved solute and crystalline solute. Even if both processes of dissolving and crystallizing out of solution continue to take place. So basically, when we talk about equilibrium in solutions, no more uh, crystals or crystalline solute are dissolved even if both processes of dissolving and crystallizing are still taking place. Okay, so in this diagram, we have for letter A, for example, solute is still dissolving. As more solute is dissolving, some are still crystallizing. But for the saturation equilibrium, when saturation equilibrium is established, this means that even though crystallizing and dissolving continues to take place, uh, the number or the amount of dissolved solute and crystalline solute is still the same. There are three different types of solution. So the kinds of saturation for the case of solutions are as follows. We have a saturated solution wherein which is a type of solution with solute that dissolves until it is unable to dissolve anymore, leaving the undissolved substances at the bottom part. So there are still a few particles which are not dissolved. When we talk about unsaturated solution, on the other hand, this refers to a solution with less solute than the saturated solution. It means that the solute are completely dissolved, leaving no remaining substances. So, jutay na lang gid or wala na gid yung gani as compared to the saturated solution. For the supersaturated solution is a solution with more solute than the saturated solution. It contains more undissolved solute, therefore, so it contains more undissolved solute than the saturated solution because of its tendency to precipitate and crystallize. So kung nantawon ta, mas damo later on ya kung nantawon ta ang undissolved na solute sa isa ka supersaturated solution compared to an unsaturated solution and a saturated solution. To be specific, let us first have what we call the saturated solution. In figure number 1, we have a lot of particles here. Given a lot of particles, this figure here illustrates an example of a saturated solution. In figures 1 until figure 1.2 until figure 1.3, there is a constant amount of water in all these beakers. For figure number 1, it is already starting, or the solute is already starting the process of saturation, where the solute starts to dissolve, represented by the red arrows. So these arrows are representing the process of dissolution for the case of the solid solute. In figure number 2, it is noticeable that a lot of solid solute has already dissolved. So these are represented by, once again, our red arrows. But not completely, for the reason that the process of crystallization has begun. If we take a look at the last beaker, only a small amount of solute solvent remains undissolved. So jutay na lang. In this process, the rate of crystallization becomes stronger than the rate of dissolution, causing the amount of undissolved to be less than the amount crystallized. So mas damo pag ang mga na-crystallize ang mga uh, particles. Okay, so that's for the case of saturated solution. An unsaturated solution, on the other hand, is a type of solution as earlier mentioned. Okay, so it is a solution with less solute than that of a saturated solution. So we go back. In this figure, we are illustrating an example of an unsaturated solution. In figures 2.1 until figure 2.3, there is a constant amount of water once again in all of the beakers. So in figure 2.2, there is an obvious difference of that, or I mean that a large amount of solute is already being dissolved from the first figure. After this, the size of the red arrow has become bigger. Okay, nagdako ng size ng red arrow. And this means that the rate of dissolution becomes greater than that of the rate of crystallization. And if we notice, unlike for the case of the saturated solution, by the last beaker, the solute solvent has completely dissolved in the liquid solvent. So basically, this means that when the rate of dissolution is already greater than that of the rate of crystallization, the amount of solute in a solution is totally dissolved. Okay, we move now to a supersaturated solution. The third type of solution is supersaturated. This illustration here represents an example of a supersaturated solution. In a supersaturated solution, as shown in figure 3.1, 3.2, and 3.3, there are still constant amount of water for all the beakers. 3.1 here shows that the beaker with more solute than the saturated solution. So earlier, if we notice, there is a large amount of solute here. So the large amount of solute begins to dissolve. By figure 3.2, if we notice, crystallization begins and causes the solid to crystallize. So mas damo na crystals sa figure 3.2. And as the solid continues to crystallize, it slowly decreases the rate of dissolution. So if we notice, as dissolution tends to decrease here, crystallization is increasing. So their relationship is inversely proportional. Kagina, for example, ang balko, sa nagtaas ang dissolution compared to crystallization, naubos tanan dissolve ang aton nga mga solute. For the case of this figure, figure 3.2, crystallization is increasing and dissolution is decreasing. And by the last figure, we notice that the solids become crystallized and form uh, they become crystallized and they form harder. This goes to show that when the rate of crystallization is increasing or greater than that of the solution, crystals will be formed in a solution, making the solution supersaturated. In this type, for example, of diagram, we have here an unsaturated solution. So an unsaturated solution actually contains particles or still undissolved particles. When we talk about saturated solutions, we are in the process known as dynamic equilibrium, which means there are only a few solute dissolved in the solvent. When the particles or solute particles are already dissolved, it becomes unsaturated. If I notice, wala na ta mga dissolved or undissolved particles. When the particles are, when there is no more precipitate, wala precipitate, kag wala na undissolved particles, the condition or the solution becomes super saturated. And lastly, when there is still, nagbalik naman for example, ang particles naman, may-ari to the particles, it becomes a saturated solution once again. Okay? So, before we end, let's have, for example, a supersaturated solution example. Have you ever heard about cloud seeding to make them produce rain, ang mga clouds? This one, for example, ginadagdagan sa eroplano. Clouds are mass of air saturated with water vapor. And in order for these crystals to be seeded or to form water particles, silver iodide crystals are dusted into the clouds as seed. Out of that, the silver iodide attracts the water, forming droplets that attract others. So, if ever you see around you airplanes dropping silver iodide in the sky, for example, towards the clouds, they are doing what we call the cloud seeding. That ends our discussion for today. Thank you once again. This is Flip Lectures in Chemistry.